We often think about how we need healthy soils to grow healthy crops, but have you ever wondered what's happening in soil at the chemical level? Let's take a quick look at soil chemistry and why two tiny soil components, clay and humus, are essential for healthy plant growth. Let's dig a bit deeper, literally. Clay and humus are the smallest particles in soil. Clays are mineral particles that come from the weathering of rocks, and they are often smaller than a bacteria, while humus is a complex mix of tiny particles and molecules coming from the natural decay of organic matter in soils. Both clay and humus are chemically active as they have a large surface area relative to their size and carry negative electrical charges on their surfaces. These charges can attract and hold positively charged ions known as cations, which include nutrients like calcium, potassium, and magnesium that plants need to grow. The way clay and humus interact with these ions affect not only the soil's pH, but also soil fertility and the capacity of soils to retain soil organic matter, which are all key for soil health. Now, let's explain these chemical properties in more detail. We will be looking at pH, cation exchange, as well as flocculation and aggregation. pH. Soil pH is a measure of the concentration of the hydrogen ions in soil. Hydrogen is a cation, but it's not a nutrient, so we don't want too many as it would make the soil too acidic for roots and microbes to live well. The pH scale measures from 0 to 14, where 7 is neutral. Figures below 7 are acidic and figures above 7 are alkaline, also known as basic. pH will affect all chemical reactions happening in soils, how roots and microbes access nutrients, and how the other cations are exchanged and released from clays and humus. Cation exchange. Cation exchange is the ability of soil particles to attract, retain, and release cations, which are attracted to the negatively charged surfaces of humus and clay particles. As you know, positive and negative charges attract each other. Clay and humus can release cations that are absorbed onto their surface and replace them with other cations, a strategy used by roots and soil microbes to access these nutrients off the shelf when they need them. Flocculation and aggregation. Particles in soil can cluster together to form larger structures, typically made of clays and other minerals glued together with humus. The small initial clusters are called floccules and are primarily made through weak chemical bonds, many of them promoted by soil cations in a process called flocculation. These structures are later cemented together with other minerals and larger organic particles to form stable structures known as soil aggregates, which are important as they help protect the organic matter in soils from further decay and enhance soil porosity. Soil pores contain water and air and are the habitat for much of the soil life, like roots and microbes. In conclusion, soil chemistry might sound complex, but it's all about understanding how particles like clay and humus help manage nutrients, support soil structure, and balance pH, all of which are key for healthy crops and productive farming. Knowing your soil's chemical properties is an important step in good land management and in achieving better results in the field.